I was asked by Steve and others to give kind of a recap over the meteorological and weather events that led to the flooding that we've had on the three recent events, that is July 16th, July 20th, and July 22nd. So I'm going to take about 5 to 10 minutes and do that, and then give kind of an outlook for the rest of the convective season, the rest of our monsoon, to kind of let you know what's coming up. We're a part of history. We really are, whether we like it or not. The combination of natural events that have occurred over the past month have led to flooding which is of historic proportions, the magnitude of which in this area really has not been seen by probably anybody here. Next slide. A lot of you, I know, whenever you hear thunder or you hear the rain on your roof, are wondering, is this going to be another flood event? Am I going to wake up tomorrow morning and see water around my house or rocks in my yard or more of that black ash in the area? The National Weather Service stands in that gap to answer that question for you. And the way we do that is through our primary mission, and that is issuing watches and warnings when there's life-threatening weather impending. Many of you, of course, are aware of the flash flood warnings that have been issued over the past week. The initial warnings for the past three events, July 16th, July 20th, and July 22nd, were all issued by our forecasters when they saw some predefined thresholds met that we saw the conditions that we anticipated flash flooding in your areas. Next slide. What I'm going to do is just very briefly give you kind of a graphical example, and I apologize for how small these are, but just to kind of give you a feel for some of the meteorology and the rainfall that fell during these three events. So you can kind of gauge for yourself the magnitude of rain that fell and the magnitude of the response of the flooding during each one of the events. Okay, this is from the July 16th event. Essentially what you're looking at here is a color graphic from our radar which shows the storm total precipitation, or at least the radar's estimation of that. During this event, we had approximately 1/4 inch to 3/4 of an inch of rainfall fall primarily over the northern area of the burn. And you can see that in the darker blue and the light blue, basically where the arrows are pointing to. The response that we saw from that, the flooding that we saw, was basically in the North Timberline area. It was a lesser flood event compared to, of course, what was coming on July 20th. The rainfall rates factor in very significantly to how fast water runs off during a typical flood event. In this case, we saw rainfall rates of 1 to 1.5 inches per hour, but it didn't last that long, so it only accumulated, like I said, to about 1/4 to 3/4 of an inch of rainfall over a part of the burn area. What I'm going to show you next will be some radar reflectivity images from the next event, the big event, July 20th. Anywhere you see red is bad in this image. Essentially, you're looking at very heavy rainfall. What is outlined in blue is the Schultz fire area. So here we are at 1:20 p.m. at the time that the flash flood warning was issued in this case. We had just starting over the area some very heavy rain falling. The first recorded precipitation on the ground was at about this time, actually about 5 minutes before this time. Go ahead and go to the next slide. And you'll see that 20 minutes later, not much had changed. Torrential rainfall was still falling over much of the burn area. Most of the time we see motion in these storms. In this case, they were stationary over the highest sensitive area we had, and that was the Schultz burn area. Next slide. About 20 minutes later, you see very little movement again. The storms had built back toward the west a little bit, toward the higher terrain, relieving some of the lower terrain of the greatest rainfall intensity. Essentially, we had a 45-minute period of torrential rainfall falling at a rate of 3 to 4 inches per hour. Extremely heavy rain. Next slide, please. And what you see here is the end result, the storm total precipitation image once again, showing in green, surrounded by white, which is the Schultz fire burn area perimeter, the area where we had approximately 1.5 to 2.5 inches of rainfall in this very short period. Now notice though, just off to the north and west, to the upper left part of the Schultz burn area, is even heavier rainfall, an area that likely received 3 to 4 inches of rainfall, which did not fall over the burn area at this time.